Well, hello guys, here Mr. G with another video. This time we're going to be solving a question for the grade 10. This one was question 8 in the question paper done in November 2024 at Gauteng Province. But before we carry on, don't forget to subscribe for the channel and like the video. This question is a electric circuit and is very much applicable for the grade 11 as well as the grade 12. In the question say, in the circuit diagram below, each cell has a voltage of 1,5 volt. Okay, that one is in terms of the battery. Each cell will have 1,5 volt. Use the diagram to answer the questions that follow. What is the reading of V1? And V1 is reading the potential difference of the battery. Guys, the potential difference, let me, use another color. This one is question 8.1. The potential difference of the battery in this case, V1, is equal to the addition of all of them. You have 1, 2, 3, 4, and 5 cells. So it will be a 5 times a V of one cell, which is equal to a 5 multiplied by 1,5, and that will give you 7,5 volts. So V1 is equal to 7,5 volts. You can also add all of them, like 1,5 plus 1,5 plus 1,5, so on up until you get 5 of them. But it's the same calculation. This one is simple math. All you need to know is because they are in series, you add them up. That is the thing. That is the potential difference of the battery. Calculate the following: total resistance of the circuit. Now, to calculate the total resistance of the circuit, the first thing you need to do, this one is 8.2.1, is that the total resistance of the circuit external, we're going to call it external, however that is for grade 12, we know that they are in series plus are in parallel. We have one resistor in series, which is this one here, and all these ones are in parallel. Okay, so we have to calculate the R parallel there. So what I want you to do is to calculate this one separated. Okay, so let's calculate the R parallel first. Now for the R parallel, here you have the formulas. This formula here is for resistors in parallel. Okay, so that one is the one that is going to help us there. So here we're going to write 1 divided by RP is equal to 1. Let me fix that equal. 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3, because we have in 3 resistors. So we are going to substitute, guys, quite simple. It's 1 divided by 6 plus 1 divided by 4 plus 1 divided by 3. Now when you solve that, you get that 1 divided by RP is going to be equal to 3/4. But note the following: the RP is the denominator, so be careful. All we have to say is that RP is equal to 3/4 to the minus 1. In other words, we invert the number. So RP will be equal to 1,33 ohm. Now we come here and we substitute in the formula for the R external. So there we go. R external is equal to RS, which is 2,67 plus 1,33. So the R external is equal to 4 ohm. So this one will give you 4 ohm. Guys, that is the first answer for question 8.2.1. Okay, now the marks here. Let me give you an idea how are the marks going to be given. There is 1 mark for this substitution. Sometimes they give for the formula, not all the time. They gave 1 for that substitution. They gave 1 for this addition here. And obviously there is 1 mark for the final answer. There is 3 marks. Calculate the following: the reading of A1. Now A1 is calculating the total current of the circuit. Now for this one we have to use Ohm's law, and Ohm's law is not in your formula. It should not be done in grade 10, but guys, it's quite simple, so it's nothing to worry about. This is a very easy formula. So we're going to even do it here. It's more than enough space. 8.2.2 2. For this calculation of current, we're going to say that current is going to be equal to potential difference divided by resistance. Because we are working with the total current, we are going to use the total potential difference and we're going to use the total resistance. It's quite simple. So current is going to be equal to the total potential difference is the one of the battery is 7,5 divided by the total resistance, which is calculated and equal to 4. So when you calculate the current, you will get 1,8788 amperes. That is the answer for this specific ammeter there. Now, how do we mark this one? This is one mark for this formula, one for this substitution, and one for that answer. It's quite simple. This formula is not given to you because it's not part of the grade 10. It will be done in grade 11. However, it's quite simple. The formulas, if we go back here, I didn't look, I didn't see it. So I look there, I don't see that formula there, as you can see, because it is not part of the grade 11, but it's the grade 10. But it's not a big issue, it's very simple. Calculate the reading of V2, and now for V2 we are going to reuse that formula, same formula for V for this resistor here. We do have the current, remember in series the current is the same, so that current is going to be the current that flows through that 2,67 resistor. So we are going to use the same formula. This one is going to be question 8.2.3, yeah? See, 8.2.1, 8.2. Yes, 8.2.3. Same formula. So current is equal to V divided by R, but now we're working only with this resistor here, guys. So now in this case we're looking for V. So what is the current? Current is going to be the same calculated, 1,88 equal to potential difference, we're looking for that one, divided by the resistance. Resistance is not total, we're working only with this one, so it's 2,67. So when you rearrange this one, you will get that potential difference is equal to 5,02 volts. That is the answer for this V2. This is V2. Okay, so that is the answer. And guys, marking the same. This time they gave 1 mark for the substitution and 1 for the final answer. Okay, they didn't give the mark for the formula because you just used that formula. So that is the first calculation. And then determine the magnitude of the charge that flows through A1 in 6 minutes. A1 is that one there. Now that formula is given to us. Let me show you here. There is the formula for charge, which is related to current. In actual fact, that is the definition for current. If you rearrange this one, if you rearrange it, you get that current is equal to charge divided by T. We read this one as rate of flow of charge, and that is the definition for a current, in case you don't remember. So that is the formula we're going to use, and guys, it is the definition for current. So we're going to come here, we're going to say this one is 8.3, charge is equal to current multiplied by time. Current, we did calculate it, is 1,88, is 1,88 multiplied by the time is given in minutes, no good, we have to multiply. So I'm going to do it in the substitution. I'm going to say 6 times 60 because 1 minute have 60 seconds, it must be in seconds. And it's very easy, you will get that the charge is equal to 676.8 coulombs. We are done. So this one is the final answer here. And yes, marking wise, 1 mark for the formula, 1 for the substitution, 1 for the answer. Guys, this question is done and the question paper is also done. I'll have a look to the multiple choices. The only question we didn't answer, if I have a chance, I will answer the multiple choice, but I want to start with chemistry as soon as possible, which is the part of physical sciences that give you more troubles. Guys, thank you for watching. I hope you understand. Thumb up, subscribe for the channel. I'll see you next time. Mr. G here.